Alright, so before moving along, I wanted to cover some general concepts that will occur quite frequently in this course. So the first is main diagonal or the principal diagonal. So let me write it down. The main diagonal or the principal diagonal. Alright, and let me explain what a main or a principal diagonal is by giving you a few examples. So let's consider a 3 by 3 matrix. So let this be 1, 2, 3, 4, 5, 6, and 7, 8, 9. So the main diagonal here would be this diagonal in the matrix, comprising of elements 1, 5, and 9. Alright, let's consider a 3 by 4 matrix with the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And the main diagonal here would be this guy. So the main diagonal elements would be 1, 6, and 11. And finally, to end the explanation, let me just take one more example. So let me consider now a 4 by 3 matrix. And let's say the elements of this 4 by 3 matrix are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12. Alright, and the principal or the main diagonal of this matrix would be the elements 1, 5, and 9. So more formally speaking, the main diagonal of a matrix, say A, alright, is the collection of entries Aij such that I is equal to j. And this definition is straight from Wikipedia. So let's consider the first example here. So the 1 is the first row and the first column. 5 is the second row and the second column. 9 is the third row and the third column. So 1, 5, 9 is the principal diagonal. In this case, we have 1 is the first row and the first column. 6 is the second row and the second column. 11 is the third row and the third column. All right. So 1, 6, 11. These three guys constitute the main or the principal diagonal. And again, in this case, the third example, this example, 1 is the first row and the first column. 5 is the element belonging to the second row and the second column. And 9 belongs to the third row and the third column. So 1, 5, and 9, they constitute the principal or the main diagonal in this case. All right. So hopefully the definition and examples sufficiently illustrate what the main diagonal of a matrix is. All right. So now let me consider. I think I've already spoken about square matrices, but just to repeat it again here. So a square matrix is the one where the number of rows is equal to the number of columns. Okay. So any 2 by 2 matrix, any 3 by 3 matrix, any 4 by 4 matrix is a square matrix. Okay. And okay, now let's move on to something more interesting. So let's talk about diagonal matrices. So let me again write it down. Diagonal matrices. So a diagonal matrix is a square matrix whose entities or whose entries above and below the main diagonal are all 0. So let's consider a few examples. So let's say, let me just create a diagonal matrix here. So 1, 0, 0, 0, 4, 0, and 0, 0, minus 1. Okay. So in this case, the principal or the main diagonal is this guy, 1, 4 and -1, and all the entries above and below this diagonal or the main diagonal are 0. Okay. You actually might remember that that the identity matrix that we have considered, any identity matrix, is actually a diagonal matrix, right? So let's consider a 3 by 3 identity matrix, and this is the 3 by 3 identity matrix, and this, the principal diagonal, is 1, 1, 1, and all the elements above and below the principal diagonal of the identity matrix are 0. So hence this is a diagonal matrix. A diagonal matrix whose entries on the main diagonal are all equal is known as a scalar matrix. So say M equal to C0, 0, and let this be an n by n matrix. So C0, 0, and then 0, C0, and then we have zeros all the way, and so this is an n by n matrix. So you would notice that in this matrix M, the principal diagonal or the main diagonal, the elements are all equal to C, where C belongs to some real number, the real number set, and M would be called a scalar matrix. So M is a scalar matrix. And some of you must have already noticed that M is equal to C times I, where C is any scalar and I is an identity matrix. All right. And last, we learn about triangular matrices. So again, let me write it down. Triangular matrices. And a triangular matrix is a special kind of a square matrix. And a square matrix, just to remind you, is a matrix that has the same number of rows and columns. So a triangular matrix is called a lower triangular matrix. It's called a lower triangular matrix if all the elements above the main diagonal are 0. So let's say L is equal to 1, 0, 0, and let's say it's 2, 3, 0, and 4, 5, 6. All right. So the main diagonal of this square matrix is this guy, 1, 3, 6, and all the elements above the principal diagonal or the main diagonal are 0, right? So this is a lower triangular matrix. And by symmetry, we have also something called an upper triangular matrix. So let us write it as U. And an upper triangular matrix is a square matrix whose entries below the main diagonal are all 0. So an example would be, let's say 1, 2, 3, and then 0, 4, 5, and then 0, 0, 6. All right. So this guy here is an upper triangular matrix. Okay. And you can see that the main diagonal here, which is this guy, 1, 4, 6, and all the elements below the main diagonal are 0. So this is an example of an upper triangular matrix. All right, I'll see you guys in the next lecture.